Okay, thanks to BostonCHI for inviting me here. I'm really excited to talk to you today about Scratch, talk to you a bit about the ideas that went behind Scratch and how we work in the team, and then have you all play with Scratch. I'd love to have you all play with it and then get your feedback. So before I get started, well, thanks for the introduction. Before I get started, I'd like to just ask, how many of you have seen Scratch before, know what Scratch is? Okay, that's a lot of you, but not everyone. That's great. Before I talk about the design principles in Scratch, I just want to give a short intro into the history of Scratch, where the idea came from, how the community has taken off ever since we launched the Scratch and the website, some statistics, and then I'll get to my presentation, and then we'll spend about half an hour together playing with Scratch. Hopefully, if you can get the Wi-Fi access, you can download it and play with it, and share your projects on the web. Do we need to help people with the Wi-Fi yet, or wait until later?
I think if you just turn on, it'll pick it up immediately and log in.
Okay, so all right. And then hopefully there'll be time at the end for questions. So where did the idea for Scratch come from? Well, in the Lifelong Kindergarten Group, which is where I work at the MIT Media Lab, we work on technologies for kids and creative expression. So we like to work on different technologies to make different tools to make technology more accessible to children. A project that we started 10 years ago is called Computer Clubhouse Network, and it's a network of after-school centers that are in urban communities, low-income urban communities, where kids are expected to come in on a voluntary basis and learn how to use technology. So they learn how to use things like word processing and the internet. And an activity that became really popular was like media manipulation and media tools. So Photoshop became really popular. Kids really like bringing in pictures of themselves, pictures of celebrities, and doing mashups. They like recording their voices and writing songs and doing poetry, and they also really like doing music videos and radio stations. A lot of these clubhouses have studios inside of them. So we were really inspired by the way that these kids, took technology and just were really expressive and really creative with it. But we noticed that they weren't doing a lot of programming. There wasn't a lot of computational thinking involved, and we thought it would be important for them to learn how to use computers to build tools on their own, not just use tools that other people had made for them. They're clearly very creative and really expressive, so why not bring programming into that? And also the idea for Scratch was, programming in general in our culture, especially for kids, is seen as kind of a very boring and dry activity. It's kind of a technical thing that boring people do. I'm one of them. And it's very difficult, and you have to, learn a lot, spend a lot of years learning how to program before you, and the environments aren't exactly friendly. So we wanted to democratize programming, bring it to everyone, not just kids actually, but make it kind of a more friendly experience. So that's in general where the idea for Scratch came from. So I'll just quickly show Scratch, how it works, some of the projects that you can build in Scratch. I'll show the website, I'll show some statistics, and then I'll get into the design principles for Scratch. So when you first, can I close your machine, Doug?
Yes.
This over here. When you first open Scratch, this is the interface that you see. All the panels are here, and there's a stage there, over there on the right with a cat. And the cat doesn't do anything. You can just move him around, but he doesn't do anything on his own. So if you want the cat to do something, there are these categories in the top left that are color-coded. The first one says motion in blue, and there's these blocks underneath. I can just bring out this first block into this middle pane and double-click it and just see what it does. It says move 10 steps. Every time I double-click it, he moves 10 steps. I can bring out the second block, and it says turn 15 degrees. And if I double-click that, I'll see what he does. He turns 15 degrees to the right. If I want to write a script, have both of these things happen at once, I actually just have to drag the block near each other, and they attach, kind of like puzzle pieces. And now that they're one script, it's my first script I've ever written, and I can double-click it, and he does both things. He moves and he turns. I haven't had to type anything. I can have him go in a full circle if I keep clicking, 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 but it's kind of tiring. So we have another category here, control, the second category there. And there's this C-shaped block here. It says forever, and it's in the shape of a C, which kind of invites you to put blocks inside of it. So when you do, you've made a loop, which now says forever, move and turn. So when I double-click on this, he moves and he turns. So now he's doing it on his own. And I've written my first animation. Then I can have him maybe stamp copies of himself, and I can maybe change the color, I don't know, have fun, bring in different blocks. And this is more or less what it's like to program in Scratch. Scratch comes with some sample projects of different types, animations, games, and stories. I'll open up a game that it comes with called Fish Chomp. And in this one, the first thing that I want you to notice is that it has more than just one character. It has 4 fish. And each fish has its own set of scripts. In this case, the first 3 fish, I'll do the same thing. But then the 4th one is kind of special. If I run this project, what's happening is the big fish, he's following my mouse cursor, and he's chomping out a little fish. Oh, let me plug in the sound. See if this will work. Oh. Let me test the sound real quick. No, it doesn't seem to be. Okay. So every time I eat one of the fish, there's a sound that plays too. And you can imagine this having a score, maybe having multiple levels, but it's just one of the samples of a project that comes with Scratch. Okay, great. You've seen Scratch. How does it work? I made a project. It's really cool. I want to share it with someone. So what do? There's a share button right in the interface at the top. So you click share, you enter your credentials, some notes about the project, and you click OK. And if you have a connection, then your project should go. Oh, I forgot to start with my actual first slide. For those of you on Twitter, this is my name and the Scratch team's name if you want to follow us. So once I've made a project and if I want to share it on the website, I go in the interface, I click on share, I enter my information, I click OK, and then it gets uploaded right to the Scratch website, and it goes right under newest projects right away. So already I'm on the front page when I've made my first project. And then if I want to explore other projects on the website, I can scroll down. There are featured projects, popular projects, my friends' projects, etc., and I can have fun. And I loaded up one of the featured projects recently. And actually, you can click on a project right in the website and interact with it. You don't have to download Scratch to play. I could have made that game, and I want my little cousins to play it. I just send them the link to my project, and they can play with it right in their browser. Here's like a recently featured project of a virtual hermit crab, and I can have it drink things and climb. I actually opened this a while ago, so he's already 95 years old. And I forgot to feed him, so he should be dead. But I'll feed him now. So you can interact right in the website with the projects, and if I wanted to see how the project was made, I would just click on this link on the right here, download the project, and I would see the blocks. I'll talk about that a little bit more later. And then down the bottom, if I want to give some feedback, I can leave comments here, right here on the page too. So it's a very social experience. We launched both Scratch and the website together 2 years ago, in May 2007, and since then the community has really taken off. I got these stats this morning. We now have about 450,000 projects on the site, which includes 11 million scripts, 3 million sprites, but more importantly, 70,000 active contributors on the site, close to 70,000 out of 300,000 registered members. And we suspect even more than that have actually downloaded Scratch, but we don't have exact numbers because a lot of times a teacher will download Scratch and distribute it to their kids, etc. So we don't have an exact count of how many people are using Scratch, and it's available in 50 languages now. So that's just a quick, and the popularity of the site has been increasing since we launched. There was a spike in May 2007 when we launched on the site, but ever since then, a lot of projects have been uploaded. This is the number of projects per day. We're up to about 1,500 projects a day now, which is roughly a project a minute. So when you make your project and you upload it, it's really only up on the website for a good 5 minutes until three more new projects have come in. So it's pretty popular. And kind of the age demographics, just quickly on the site, we've noticed that it peaks between 8 and 16 years old, and it ends up peaking at 11 and 12. We did design Scratch for the preteen age, so it kind of makes sense. We do have some younger users, but more notably, a lot of adult users on the site too, which we didn't really expect, but we end up having retired engineers, grandparents, parents. They hang out on the site. They have a lot of fun, hobbyists. But again, it peaks at around 11 and 12. So now I'd like to just share with you a bit about our design principles in designing Scratch on the past 6 years. I've been on the team for 6 years, as Doug mentioned. A bit about our design process within the group, and then we'll hopefully get to have some time to play too. I want to have you all use Scratch and experience it. And hopefully at the end we'll have time for questions. So I'll try to go quickly. So I mentioned that we wanted to make programming more accessible. We set about to do that with these 3 main design principles. We wanted programming not to be boring and dry and difficult, but we wanted it to be more tinkerable, playful. We also wanted it to be more meaningful. Early on, when there were programming languages for children like Logo, etc., a lot of the introductory activities were, make factorial or make, a random number generator or something that wasn't really interesting to the kids, draw some simple shapes. But we wanted to, with Scratch, we wanted to make sure that the experience for programming was personally meaningful, a lot like the media manipulation that the kids did at the clubhouses, something that came from them that was an expression of what they wanted to do. And we also wanted to make programming more social. I was talking to some people earlier, programming, sometimes seen as a very solitary activity. Someone's in a cubicle and they're just always programming on their own. But the social web is everywhere these days. Kids love, YouTube and sharing and user-created content, and they just love giving each other feedback, making things together. And we wanted programming to feel that way too. So yeah, so we wanted it to be more tinkerable, more meaningful, more social. So I'll show soon. In a second, I want to show you what we did in the interface and in Scratch to get at these 3 design principles. But before I go there, I just want to show this graphic quickly, because it's kind of like the overarching principles that we've used when we design all our tools in the group. And this comes from Seymour Papert, who designed the first version of, and he's been the mentor for Mitchell Resnick in our group. So most importantly, we want all of our tools to have a low floor. We want them to have a low barrier to entry. We want everything to be pretty easy to get started with. We want our tools, as soon as you pick them up, within 5-10 minutes, you're already going. You don't need a tutorial. You don't need to go to YouTube and watch 10 videos. You don't need to have someone teach you. You should be able to just use it. It should be intuitive or simple. However, if you really want to get involved and make something complex, then we wanted to also support a high ceiling. We wanted to support those people who want to go further and get really complex and make something, more technically complex. And lastly, we also always want to support a wide walls, a diversity of activities. We don't want to just support game making or storytelling or any one particular activity. People find very many different things meaningful. So why not support as many activities as possible? So we wanted a general toolkit as opposed to any kind of purposeful tool. Yeah.
Could this be saved in file formats that can be opened by other people without the application?
Scratch? That's a great question. The current answer is no, unfortunately. We get asked that all the time, and it gets at you can share on the website, and you don't have to download you don't have to download Scratch to view files on the website, but not everyone has the internet. We're looking at ways to package it up as a jar file that can be distributed. We have prototypes that work. We might also try a Flash player version of it. So we have prototypes, but nothing that works really well. That's one of the most common questions, and the kids really ask for it. They want to put games on CDs and hand them out. So now back to the 3 design principles. How did we make programming more tinkerable? I would say that our biggest inspiration was Lego. We have a lot of people in the group who have worked with Lego in the past. Mitchell Resnick is actually on the board of, advisors at Lego. And we've always been inspired by how kids play with Lego blocks. With Lego blocks, you snap them together. You don't really have a plan. You have a messy workspace. You make a stack over here. You see where it goes. You make a stack over there. You see how it goes. You can unsnap, Lego blocks together, resnap them together, and eventually a design emerges. Unless you're building, those crazy Star Wars things that they package up nowadays. But back when you played with Legos, kind of the regular way, you just played around with these colorful things that were really playful. And there was no plan. You just something eventually. You built something eventually. So that was definitely an inspiration for Scratch, is making programming feel something like that, tinkerable and playful like that. We also wanted the workspace to be really interactive. Programming usually has this workflow where you type something really long and complex. You have a lot of errors. You have to be very careful. Then you hit compile. Then you hit run. Then you see what you've done, and there's an error. And then you have to go all the way back and say, oh my God, what did I do? Where did that come from? And start all over again. It's this very linear process that can be kind of discouraging. And in fact, usually when you program, there's a lot of errors, like, no, you forgot the semicolon, that this parenthesis, and there's a lot of errors in these like IDEs, and it can be really you can crash your whole computer when you're programming, and it can be really daunting to program. So we wanted to do away with as many, have as little few errors in Scratch as we could have. So I'll just quickly show in the interface what I mean. So like I said, the blocks were really meant to feel sort of like Lego blocks, so they are physical. You drag them out. There's no typing. They snap together. I can make a stack, and remake a stack and undo it. I can reorder things. I can just quickly, mix and match. I can make 2 stacks if I want, have one over here somewhere else that I'm experimenting with, etc. And in the notion of tinkering, we also wanted development to just feel something that was quick. You don't have to compile. You don't have to compile and run. So, for example, this program that I wrote earlier, where the cat was going around in a circle, if I had that running, but I wanted him to make a bigger circle, here I'll make him stamp himself too, and do the colors. And I'm like, okay, that's cool, but I want to try a bigger circle. Let me see. I'm going to change this 10 into a 20 and press enter and see what happens. And I haven't had to stop the program or rerun it. It just changes right away. And I can just type some numbers. I can experiment with more numbers in here. What's 25 do, etc. So that's how we made it tinkerable. And then as far as errors, pretty much any block that you click on will do something. It's not going to yell at you. It'll either do something or do nothing if the value doesn't make sense. For numerical values, if you type in, for example, move 1 divided by 0 steps, that really isn't a valid value. So what would we do then? Well, we just highlight the block in red. And that means something's wrong in here. In our very latest version of Scratch, which I'm not showing right now, the 1 over 0 would actually also be in red. But that's about as far as we go. We just try to give some indication. But it definitely tries not to yell at you. And I just mentioned something quickly about the grammar. Even though we wanted to feel like Legos and we wanted to feel like playful and have all this color coding, there is some notion of programming grammar in the blocks. So for example, all commands are just regular blocks that stack on top of each other. But loops, like I've already shown, are in this special C shape. So they kind of suggest that things belong inside, and they can also be in a sequence with other commands. Events, you can't put anything on top of an event because the idea of an event is that it's the trigger. And we also have some visual cues for typing of variables of values. So numerical values are all round, and Boolean values have these angle brackets on the side. And those are just supposed to be cues to help you program. So for example, in this conditional block that says if, all it accepts are Booleans. So I can't drop a circular block into a triangular space. I can only into an angled space, but I can drop this angled block into this angled space. So the Boolean blocks fit into Boolean slots only, etc. Oh, sorry. How did we make programming more meaningful? I've already mentioned a bit the wide walls. We wanted to support a diverse set of things, of activities. Some people really like games. Some people really like stories. Some people really like art and sound. So we wanted to build in as many different features as we could into Scratch to let you build those different kinds of projects. We also wanted to support personalization. Again, from those kids in the computer clubhouses, we noticed that they really liked their own pictures and their own voices in a lot of the things that they do. So it was really important for us in Scratch for kids to be able to not only use the prepackaged pictures that it comes with and the prepackaged sounds, but also bring in their own pictures and their own sounds, MP3s, anything that's really meaningful to them or personal to them. And I'll briefly mention connections to the physical world, which some people find tangible things really meaningful, sensors, actuators. So we did build in a bit of that into Scratch. You can buy something called the Scratch board, which I didn't bring, which has some sensors on it. It has like a light sensor and a sound sensor, etc. And you can hook that up into Scratch and use those values from the sensors to run your project. And people find that meaningful too. It's not free, so I won't be able to show that. I didn't bring it. But again, in Scratch you can do like picture effects if you want. Let me clear up the screen a bit. If you're into art, you can do graphics effects. There's a whole looks category. If you're into stories, you can do animation bubbles. If you're into sound, you can record your own sound. Sorry, let me step back a second. If you want to customize this guy and you don't want him to look like a cat and you want him to look like something else, you can click up here on costumes, and you can either paint your own one. We actually have a paint editor in Scratch, or you can import a picture. So if I want it to look like me, I can bring the picture of myself, you know, and write a project that does, let's see, forever change the colors or something. So all of a sudden I'm in a disco, I guess. Or if I want to record my own sound, you know, here's the costumes tab. I brought in my picture here under sounds. I can import sounds that come with Scratch, like basic sound effects. Or I can actually, if I had my microphone working, I could like record my voice, blah, 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 you know, tell a story, and then click OK. And that sound would automatically show up in one of these blocks, and I could use it in my program too. Or like I mentioned, you can bring in MP3s and various sound files if that's what you want to do. And then how do we make it? Yep.
In theory, when you let somebody personalize something or let them control it, you have to let them make their own mistakes. How have you dealt with this problem? For example, if you let me upload my own file or a picture, you have to deal with the fact that I might bring in a file which is too heavy or whatever.
Yeah.
So how have you dealt with such problems?
Right. If a picture is too big, we shrink it. If a sound is too big, there's a limit to the file size on the projects that go on the website, and we have some compression options inside of Scratch. So if a kid says, my project's too big, doesn't fit on the site, we say compress it if you can. And then if it's still too big, then we say shorten the sound, you know, use another song. So this is, you know, we try our best, but you can't always solve all the technical issues, I guess. And right, so then we wanted to make it more social, so how did we do that? So since the beginning, the development of Scratch software went hand in hand with the development of the Scratch website. We knew we weren't gonna want to release Scratch without the website, and that had to have that social component. So we wanted publishing to be really important. We wanted to highlight it in the interface, and we modeled the website loosely after, you know, something like YouTube or these popular user-generated content sites. So we wanted to bring in commenting and friending and loving of projects and, you know, kind of the things that you would expect on these sites. We also wanted to support collaboration and remixing. So to support collaboration, we made it possible, every single project that's uploaded on the site is under a Creative Commons license, which means that if a kid goes to the website and sees a project that like simulates gravity in a game and they say, that is so cool, I want to learn how to do that, they can just click download this project, open it, and actually see the source code. And then beyond that, they can change it, you know, maybe add their own graphics, add their own version of gravity, and re-upload it up into the website, you know, create a remix, and then someone else could take that and remix it too. And early on, that was in Scratch from the beginning. But early on, a lot of kids started seeing copies of their projects kind of crop up everywhere on the website. So we got a lot of feedback, like, you know, kids are stealing my project. You know, this isn't fair. They're cheating, which was the opposite of what the reaction that, you know, we wanted. So we did build in a couple of things into the website to help with that, and I'll show that in a moment. And in addition to the website, we've also tried to set up a couple of events, social events, real, in-life, personal social events around Scratch. Last year we had the first International Scratch Conference, where we invited educators who've been using Scratch around the world to come and share their ideas and how they've been using Scratch. And that was really successful. We had about 300 people, but we kind of left out the kids, you know, and on the site they were like, we wanted to go. So this year we did something different. We called it Scratch Day. And the model was that we let other people around the world hold their own mini Scratch conferences and mini Scratch workshops on this one day, May 16th. And that was really successful. We had about 100, I don't remember, events in 40 different countries. There's a map on the web somewhere. And in this case, kids were able to also go to these events and meet each other in a safe environment, and that was also really successful. So I'll show a little bit on the website. Again, on the website, when you look at a project, you can download it. It's one of the first things you can do right here on the top, over there in the top right. You can read the project notes that the person has said. You can tag a project with different tags, like on Flickr, on YouTube, if you want to categorize these projects. One of the most popular tags is waffles, for no reason. But if your project is tagged waffles, then you're pretty cool. Then underneath, you can say, I love this project, add it to my favorites, flag it as inappropriate. I can see that since this is a featured project, 44 people have loved it. It's in 13 different galleries, etc. It has 2 remixes. And I already showed earlier down the bottom, a lot of commenting happens on the site. We wanted the kids to critique each other, support each other. This is cool, add more crabs. It's weird, but it's nice. It's a lot of fun to read the kinds of things that they have to say on there. And as far as the remixing, like I mentioned earlier, at first they felt like it was cheating. Like they saw copies of their projects everywhere and they were saying, no, what's going on? Everyone's stealing my projects. So we put in a couple of things on the website to promote remixing, and the first thing was attribution. So now on the website, if you download a project, change it, and upload it again, underneath it'll say, Kimmy shared this 4 days ago, and it was based on Solar Buddy's project. So there's attribution right underneath. And if I go to Solar Buddy's project and his was based on someone else, I can see that too. So there's an entire chain of attribution all the way to the original creator, and that seemed to help. But then the thing that helped the most is that on the front page, we actually highlighted the top remix projects. So now any project that has a lot of copies out there is going to show up here on the front page as a cool project that's really been remixed a lot recently. So all of a sudden, we started seeing kids, instead of saying, stop copying my project, they were saying, please remix my project. It was great. It really worked. And they've been really creative. They make these projects like, here's a yearbook, I've added page number 1, now you download it, remix it, and add page number 2, and they've gotten really creative with the collaboration. In fact, I was telling someone earlier, something else that's happened on the site that we didn't expect is kids have formed mini companies. So some kids started noticing that, for example, one girl was really into character creation, and so she would make a lot of just sprites and draw really nice animations. And someone else was really into designing games, and someone else was really into just the programming aspect. And they started noticing each other's qualities, and they would start talking to each other and say like, hey, how about, you draw the characters for my game, etc. And they started forming mini companies, even though they were in remote parts of the world, and kind of setting up spaces online where they could share their ideas and release games. They had actual release dates and beta testing and everything. It's been a lot of fun to see. So the collaboration has really taken off. Sorry. So now just a little bit about our design process within the team. The first thing that I want to mention is that we have a lot of people within the team that came from many years of experience building programming tools for kids. We had people that worked on the Lego Mindstorms, the first versions of the Lego Mindstorms. We had people that worked on Squeak eToys, for those of you who are familiar with that. A lot of logo systems like Microroads Pro, for example. So what I like to say is that we didn't design Scratch from scratch. There was a lot of bias, like right from the beginning. And that a lot of years of experience. I came to the project fresh 6 years ago, but everyone else pretty much didn't. So a lot of experience went into the design. Something that was important to us from the beginning was that we all interacted with the users, especially during the prototyping phases. Early on, because we're a research group, not a company, but we were developing a product that we were actually going to release, we had Harvard business students come and meet us and just give us some tips. And they said, something you should do, they said, don't ever let your developers talk to your users. You must have a marketing person go talk to the users, and then they come back and report, and there would be too much miscommunication. And that's what we were told, but we found that didn't work for us. We thought it was a lot better for everyone in the team to go to the workshops, talk to the kids, ask them questions, see how they worked, and then we would come back and just talk it all out together, and that worked out really well for us. We all have always interacted with the users. I'm a developer, but I come give these talks. Something I probably don't have to say is that we've iterated a lot over the years, to this crowd, right? So we iterate, and something that we hope the kids learn how to do too. We design Scratch so that kids learn how to iterate over a design. It doesn't have to be perfect from step 1. But when we iterate, something really important about our process that I like to point out is that we don't add features very often. We actually let them simmer in our heads. A lot of people come in, they say, it should have video, it should do 3D, it should do this, it should do that. And we take everything into account, but we let it simmer, and we really only pick out features that we think will fit very well into the system and keep that low floor low. You know, we don't want to add too many things to make it confusing. We do want to add things to make the system powerful for those advanced users, but there's always a trade-off, and so instead of adding features, we actually remove them more often than not. When in doubt, leave it out. We do it all the time. So it's a lot of pushback from the kids, and even adults are like, why don't you add this? But our reason is, you know, that's how we work. We want to keep Scratch simple. That's always been number one. But in our design process, of course, there are limitations. These are some I've seen. Probably one of the biggest things I've seen, especially recently. Oh, sorry, did you have a...
Backwards compatibility?
Uh-huh.
Is that an issue when you remove things?
It isn't. We do think about it, yes. What happens if we happen to remove a block? I say we remove, we don't remove so often, but you know, we remove more often than we add, at least. If we remove a block that was in a previous version of Scratch, if you open up a project in a new version of Scratch, it'll show up red and it will say obsolete. So it's red in the same color as the other error blocks are. It doesn't break the program, it's just obsolete. And if it really can evaluate, then you'll get that big red outline. But we try our best to handle. But that's a great question. Right, so we have limited resources in the group. We're just the research team, and most of the people are PhD students that have their own projects to work on. There's only 2 of us that are developers that work full-time, myself included. So it's especially now that there's such a big community, we spend a lot more time maintaining website and maintaining Scratch than actually developing new and exciting things or thinking of, you know, of the next big thing, which has been hard. There's always been a tension between keeping it simple and making it extensible. One example that I'll talk about is trig functions. The first version of Scratch didn't have any trig functions. It only had like plus, minus, and divide, and maybe square root. And we thought, if you wanted sign, you can build sign, right? You should be, you know, you should be able to go find the formula and just build it out of blocks. But eventually, enough kids, you know, especially as kids started learning trigonometry, and I don't know what grade they learned that at, middle school, I don't know. They would come back and say, like, where's the sine block? Where's the cosine block? You know, so eventually, you know, what we came up with was a compromise. We came up with one block that reads square root, but it actually has a drop-down menu for all the other trigonometric functions. There's a lot of them. So if you want the advanced usage, you can go dig around in the interface, but at first view, it's just one simple block. And that was, you know, one compromise. We do that often. User testing, you know, has become harder and harder. We don't do a lot of data collection. We don't have the resources, like I mentioned. So a lot of our user testing is anecdotal, or just, you know, we go to workshops and one person notices something. Someone mentioned that earlier, that cooks struggle with that, I guess. And we depend a lot on like stories that just come back or emails that we get, but it's been, you know, it's not always easy to know if that's the right way to go or not. We haven't done a lot of just collecting of data. You know, is this block really working for kids? Is this block really working for kids? Recently, now that we have so many projects uploaded on the site, we have been able to parse them and see which blocks have been most popular over the past 2 years, et cetera. So we're just, now that we have the data, we're starting to do this kind of data analysis. But that's been an issue. Yeah.
Sure, I'm joking, but we did have a bug. Is there a way to cite for the
Exactly, yeah. How do we collect bugs? We have one emailing list right now where that it's a kind of a catch-all for anything that kids want to ask, and bugs come in through there. There's also, we have a forum section on the site that has a bugs reporting mechanism, and so between the mailing list and the forums, that's where we get a lot of our reports. But I do want to talk about beta testing. We tried with Scratch 1.2 to have a public beta test with the kids. We thought it would be fun, like teach them what beta testing is like, have them test out new features in Scratch. And one of those features was commenting. You know, in code, we wanted kids to learn how to comment code and say, like, this stack will do this, and this stack will do that. And we first implemented commenting as one of those command blocks that just goes right in with your script. And during the beta test, we found a lot of kids saying like, why, what is this block? I'm typing jump, but it doesn't jump. The block didn't work very well, and we took it out because, that's what a beta test is for. And of course we took it out, and all the kids were like, where's the commenting block? Like, what did you do with it? And it was hard for us to explain, like, no, this is a beta test, we're just testing the features, we didn't mean to promise anything. When we started having kids ask us, like, well, if you didn't want us to use it, why did you give it to us? And it was all valid, that was a learning experience for us. So with more recent versions of Scratch, we do private beta testing, and it's limiting because we want the kids to use it, but we also don't want them to get confused. So we only rope in the kids that we know that understand what beta testing is, and mostly we have adults beta testing for us. So that's been an issue. I'll talk a little bit about graphic design. The first version of Scratch, the interface, we did hire a designer to design it with us. But since then, we've needed to add new features, new buttons, and we don't want to keep hiring graphic designers. So it's mostly up to me to come up with new icons, and it's pretty challenging. I'm not a graphic designer, I'm a programmer. So one example that I'll give is the button for a new sprite. In Scratch, you have sprites, they're objects, and if you want to make a new one, how do you do that? We don't have a menu item, we wanted a button. So the original graphic designer designed us this purple button with a white star. And you wanted kids to just find that star and say new sprite. And it didn't work very well. Kids would always ask us, how do I make a new sprite? And in fact, in Scratch, there are 3 ways to create a sprite. You can paint it, you can choose one from a folder, from a library of pictures, or you can get a surprise sprite. So we ended up breaking it up into 3 buttons. It's the best we could come up with, and they're not very clear. They're really cluttered, iconography is just difficult. So we struggle with that a lot. And website moderation, after we launched Scratch, we figured out, this is, it's kind of paired with the limited resources. It's been really difficult. Parents kind of expect the website to be safe, but kids will be kids, and obscene projects are up there. They make their way, and so we've had to actually hire also part-time people to censor projects. Often we put in some self-moderation, so now kids can flag projects, and if a project has been flagged more than 10 times, then we censor it, etc. But it's a continuous problem. Just even with the flagging, we can't really rely on it because the kids really love to bully each other, and they'll be like, I don't like Mario, so I don't like this project. I don't want to flag it. So that's been fun. Okay, so that's all I really wanted to say about Scratch, and I thought it would be fun to have you all use it, and I want to hear what you think. So if you haven't downloaded it, I'll come around and help you download it. But quickly, I'll just show you a sample project. I'll make one interactively with you here, and then I'll put up on the screen some blocks as an inspiration. If you get stuck and you don't know where to go, you can use those blocks. But you're free to pair up and have fun and play, and I'll walk around and help you. And then in about 15 minutes, it won't be a very long session, I'll come back and help you all upload your project to the site so you can all share it with the world. So, for those of you who have Scratch, you can play along with me, and if you don't, that's fine. Have your turn later. I'm going to make a project with my initials, 2 objects that will be my initials, and I'm going to want to interact with them a little bit and have them react, maybe change the background, and that's about all I'll do. So here's my first object. He's already there, and he's a cat, but I want it to look like the letter E. My initials are E. So the first thing I'm going to do is I'm going to click in the middle pane on the Costumes tab. I'm going to delete the second costume. I don't need it. And I'm going to edit the cat. That'll bring up the paint editor. I'm going to clear out the cat, and I'm going to draw my E. Really beautiful E. And I'll fill it in, maybe with my favorite colors. And there's my first initial. What do I want this initial to do? Let's see. I think I want it to spin around in a circle when I click on it. So first, let me make it spin. I'll go to the motion category, and I'll bring out the turn block that we saw earlier. And I'll make him turn 10 degrees. And if I click that, he just turns a little bit. And if I click it again, he turns a little bit. If I want him to turn 360 degrees, then I can have him repeat this action 36 times. So under control, there's a loop that says repeat 10, and I'll change the 10 into a 36, and now he goes all the way around every time I click this. But I don't want it to happen, I don't want it to happen when I click on the stack. I want it to happen when I click on the actual E. So again, under the control category, the third block here says when sprite 1, which is the name of my object, when sprite 1 is clicked, then do this. So it reads, when sprite 1 is clicked, repeat 36 times, turn 10 degrees. So now when I click on the E, it turns. That's what I wanted. Oh, that's cool. Now I want to make my second object. Here are those buttons I was talking about down below. And you can paint, you can choose, and you can get a surprise one. This time I'm going to choose a sprite to make my new object. And there's a category of letters, and let's see, I like the circle letters. Sorry. I'm going to pick the E, my second initial. It's a little too small, so I'm going to grab the resize button here, make it bigger. And what I want this one to do is to kind of balloon out and then balloon back in. We have an effect for that in Scratch. And when I press the letter E on the keyboard, that's where I wanted to do that. So under the looks category, somewhere in the middle, there's a block that says change the color effect by 25. But there's a drop-down menu there too. And I'm going to choose this fisheye effect and maybe change the 25 to 100. And there it's ballooned out. So I'm changing the fisheye effect by 100. But then I want it to balloon back in, so I'll bring out the same block, choose the fisheye effect again. But this time, if I want it to balloon back, I'll just put in a negative 100. That's the opposite effect. So he balloons out and he balloons in. And I want him to do that for about, half a second. So under the control category, there's a wait block. And I can have him do that for 0.5 seconds. So when I click, he balloons out, he balloons in, he balloons out, he balloons in. And I want it to happen when I press the E key on the keyboard. So I'll bring out the second block under control category that says when the space key is pressed. But that also has a drop-down menu. All the letters on the conventional keyboard. I'll choose the E. Now when I click the E on my keyboard, he does that. Maybe I wanted to play a sound. So I'll go to the sound category and choose the drum block. And when I press the E, that's loud. He does that. So he's doing that, and he's spinning in circles, and to finish it off, I want a background, because white is so boring. So there's a special object called the stage, which is the background. He can't move, but you can change what it looks like. So I'll click on the stage, and then I'll click in the middle again on backgrounds. And I can paint one, or I can import. Scratch comes with some backgrounds. I'll just choose these flowers. They're so colorful. And my project is done. Now I'm really happy with it. So I welcome you to try the same thing, play with Scratch. I'm going to, if you haven't downloaded it, I'll help you. Here are some blocks to point you towards if you're stuck. But find a partner or work on your own, or if you're inspired by something else, bring in your own pictures, have fun. I'd love for you to play with Scratch, and then hopefully afterwards I'd just like to get some more questions. So have fun. So Ethan would like to show his creation. He's going to click on the green flag. Oh. Oh, that's great.
All right. Do a quick switch here. Function F8 is it?
What was the big idea, Ethan?
I don't know. We started making it rotate and turned it, and then we had a little bit of trouble with it.
Function F8.
It would just. It wouldn't actually turn. It would go around in a circle, but not turn. We had it on the wrong rotation set.
Right. Yeah. Ethan hit one of our biggest UI challenges is how to have kids deal with different rotation styles. We didn't want it to be programmatic, so we have this really awkward UI widget somewhere in the top, and I saw other people ran into that problem too, so I had to point it out to him. It's not super intuitive. Now, Rachel?
How do you make it full screen?
Yeah, that's perfect. Yep.
That one?
Thanks, Ethan.
Okay.
Oh, very nice.
All right.
How did you do the remaining color to leave it, make it stay on the screen?
Oh, what did you use to make it stay like that?
Yeah, so it makes it automatic.
I used the stamp.
The stamp.
Damn.
Hey, I think
like to stand.
All right, we have one more to show. My son Adam, who's been playing with this the entire time, he's 8 years old, so this is what he made. Do the full screen? Okay. So, the thing he's most proud of is the car bouncing on the trampoline.
Oh, very nice. That's great.
Good job.
Thanks, Adam. It's awesome.
All right. How do I stop this thing? The red on the top. Oh, there it is. All righty.
Great. So now I'd like to have you all upload your projects on the website, which will take a couple of minutes. But for those of you that have Wi-Fi, if you have Wi-Fi and you're ready with your project and you're ready to share it with the world, you can go to scratch.mit.edu, which is our main website. And if you don't have an account, click on sign up at the top. And you have to enter some information. And once you're done entering all your information and signing up on the website, then within Scratch, you can click on the share button and enter that information, and then click OK. So again, I guess if you have the Wi-Fi, it should go right up on the website. So if you need any help with that, let me know and I can come around. And while people are uploading their projects, since we're running short on time, if people have questions that you want me to answer publicly, please let me know.
What's the code underneath the code? What did you write the code in?
So the question was, what was Scratch written in? We wrote Scratch in Smalltalk. I don't know how many people know about Smalltalk. Yes, it was one of the first object-oriented programming languages designed by Alan Kay. In fact, the main developer on Scratch, Don Maloney, who has visited some before, he actually developed part of Smalltalk, and that's why we're using Smalltalk. But it's starting to show its age. Recently, we added localization to Scratch. So I mentioned that it's in 50 languages. I didn't show you. I could show you quickly. Smalltalk didn't have Unicode support, so we had to write it from ourselves, which took a while. But it really paid off in the end, but it took extra work, and then, yeah. Yep.
So how are the projects running on the web there?
Oh, right. We rewrote the Scratch interpreter in Java and Logo. It's a combination. So we package up an applet that has a Logo interpreter in it and some Java, and that's what the Scratch player is. Since I mentioned localization, I'll show something quickly. So there's a language button in Scratch, and if you and it comes in a lot of languages, and it took us a while, like I said, to support these characters that I can't read. This is Nepali. We worked with some kids in Bangalore, and this is Kannada, so this took us a long time to support. But beyond that, I found it really important to also support the right-to-left scripts. So something that is nice to see is that we've actually written the code to go right to left too. So even the loops, like I was showing earlier, go in the other direction. So that was something that took us a while, but we have some great translators on our teams that work with us, and it's all built in right into the system. Sorry? Oh. Guess the language, yeah. We put a lot of work into that in the past year. Because the idea is if you've programmed something in English, you share it on the website, but you don't speak English, but you still want to read the scripts, you should be able to just with a menu, switch to your language and read what's going on. Okay, I definitely don't want to keep you longer, so I think with that I'll say thank you, and thanks for coming out today.